Oh, okay, so thank you very much and good morning to everyone. I'm going to present this paper. This is a work from one of our students. So I will present, my name is David Camacho. We are from Technical University of Madrid here, Universidad Politécnica of Madrid. Right, so this is the outline of this presentation, and the goal can be easily summarized about how to use supervised learning approaches to detect or to extract behavioral patterns among players in a particular game, a very popular real-time strategy game that is League of Legends, LoL, for the gamers. So our specific goals can be summarized in the next one: how to obtain or how to analyze the most important variables that you can extract or use from this the recording of the match of the plays. So these gamers can do during any match. So we will use unsupervised machine learning methods named Hidden Markov Models to try to analyze or to extract these behavioral patterns based on the quality of this information and the complexity. And later use some kind of visualization techniques to analyze the behavior of these gamers. So our main goal is to be able to extract the behavior of the gamers and later to try to develop some kind of predictive model about how these gamers are using their strategies to win, of course, the game. So we select this game, League of Legends, because it's extremely popular, it's extremely active. So I think there's more than 100 million active users playing this game. It is a real-time strategy game, and there's a very interesting issue related to this game is that you can use macro game decisions. So you can decide macro game decisions to try to win your adversary, right? So this is, for instance, one of these macro game decisions that you can take in this very complex game because you can extract thousands of variables from these games to try to find any possible pattern. Right, like for instance, so you can represent in your general map your main objectives that you need to reach or to destroy to win this game, and your resources to win the game. So you can see here in this representation these macro game objectives. That is like the nexus, like the nexus is like the side that you need to defend or to destroy to win the game. That is these round circles in blue and red. So there's different objectives inside this game. So you can take several decisions to try to win your adversary. So the idea is how you can model the different decisions. So we have used a very well-known unsupervised method. The name is Hidden Markov Models. I suppose that is quite, maybe you have used HMM in the past. This is a very well-known statistical models with a set of underlying states. So you can you only can see the emission of different states, and you know that one state only depends on the previous state. So the observation that we are using here, it's only discrete. So we only take the emission of these discrete values from the states. And why use this kind of approach? Because they give us a very good level of abstraction. So we can use these states to represent the behavior of the user. We have used this approach based on HMM in other approaches like UAVs, unmanned aerial vehicles, for instance, to represent the behaviors of the ground control operators in the past. So the main issue related to HMM is that you have a lot of parameters, like the number of observable states. Then you need to define the underlying sequence of hidden states. There's a lot of variables, but one of the main problem is that in the majority of applications, this set of parameters that you need to fix to train the HMM cannot be automatically or analytically inferred. So you need to use any kind or some kind of machine learning method. So one of these approaches is quite popular to use unsupervised approaches like clustering. So we have used the well-known bound-weld algorithm. This is a form of the popular or the classical algorithm. So and to select the number of states, so you need to fix the different variables to train this model, and to fix the number of states. This is one of the keys, one of the key aspects of these approaches. We have used this metric VIC, Bayesian information criterion, to select where is the best HMM model that you can obtain from the data. This metric it's based on the complexity. The complexity is measured using the number of states and the information given from the different variables that you are using to train your model. Okay, so our problem statement is represented here, and more or less the methodology follow. We extract data and preprocess this data. We train layer for HMM models. Why for? Layer you can see because you have two different teams, blue and red, and you have two different possibilities to win or to lose the game. So you have finally 4 HMM. And later you will use some kind of visualization technique to compare the strategy, the global strategy. So you can see here the methodology. So we have used, okay, this game has an API provided by Riot Games, is the company that developed this game, LoL. So you can extract the data, you can filter the different games by the gamers, you can extract the different actions. So we preprocess the data in form of different events. Later we remove these games with very few events, less than 5 events were removed. Later you can put like this set of events, and you can put like a couple of labels like blue team wins or lose this match, or red team win or lose the match. So after preprocessing the data set, you can take like 4 group of event sequences, depends on the team, blue or red, and if this team win or loses the match, right? So later, as I said before, you train your HMM, your Markov model using these sequences. So you will generate for models for every of these for each of these sequences. And later you will train the models, and you will pick the models with the smallest, the best peak value. Right? But not always, because we used the data extracted from more than 7,000 professional gameplays, right? These matches, so it's more than near to 8,000 professional gameplays. And we select, finally, you can see here, like, okay, in sometimes this represent the complexity, the number of states, the number of states, right? Like 10 states are more complex that if you are using, for instance, you can see here 6 states, right? And this in the y-axis represent the amount of information that you are receiving, right? The less is the better. So in some cases, like in this case, we select a trade-off between the complexity of the model and the information that this model is giving to us. So okay, this is our visual representation of our models. So this you can see a better description, of course, in the paper we have for 10 minutes. So these states, these are the all of the states that we're currently representing in our approach, and this represent inside every state what action are the most probable that was selected by the different game players, and the width of this edge between these two states, for instance, from state 1 to state 2, represent the probability to go from this state to this state. So it's very simple to see. This, of course, represents the event sequence for the blue team when these events obtains a victory in this play. So you can see here, like if you compare the winning and losing event sequences, you can understand what did the different players, like to start taking a dragon or to put one tower in different part of your map. So this is, for instance, if you move to this, for instance, to this part of the blue events winning sequence, you can see how the most usual actions are like this. You have you can see here like two different paths. This is the most probable path when you are trying to win your match. Finishing, you can see here, like in some event sequences, it is more difficult to extract some clear pattern. So our you can see in the paper a more detailed description of this visual analysis from our HMM models. So to finish my presentation, we are trying to develop some predictive models based on this behavioral pattern that you can extract from this visual analysis that could be used to better understand what are the global strategies that are currently using professional game players. Okay, thanks. Excuse me, I have to take a couple of minutes more.